So in order to start thinking about how to hook things up to our HapKit board and control and read and output, we need to go over some circuit basics first. And if this is review for you, you can skip this section. So some basic circuit ideas are electric current, first of all, which is the movement or flow of electrically charged particles. And electric current we're going to measure in units of amperes. Sometimes it's going to be in a small number of amperes, so we'll call them milliamps. Voltage is the electric potential difference between 2 points, and this is typically measured in volts. And current and voltage being defined for a circuit is a pretty essential starting point for understanding what a circuit is going to do. Now, the circuit elements really determine how the electrical current and the voltage are related to each other. And there are a lot of circuit elements that might be available to you, such as resistors, capacitors, inductors, and diodes. And today we will actually be using resistors and diodes to hook up to your HapKit. So finally, a circuit has to have a power source and a ground in order to generate a voltage and induce current. And we'll see this more clearly when we look at a circuit diagram. And this is most easily done with an example circuit. So in this case, let's ignore the fact that you have a HapKit board there and just start with a battery. So over here we have a battery on this side, and on the right side we have a resistor. And all of these black lines here represent physical wires that are connecting these two elements, the battery and the resistor. So what I've shown on the screen now is that the battery is going to be a voltage source. And while a battery of this shape is probably typically 1.5 volts, let's just say for argument's sake that it's a 5-volt battery, and it winds up with 5 volts on the top and 0 volts on the bottom. And so I've also added a ground here just to show that I'm going to define some space in the circuit, some point in the circuit as 0 volts. Now we have our 5-volt source and we've defined our ground. So we can define that there's a current now that's going to be flowing through this circuit. It's going to flow from high voltage to low voltage, so that's why I've drawn this arrow the way that I have, and the variable for current is going to be I. And at the moment we haven't defined what the value of that current is. I just like to draw a line there showing that there is a current flowing and the direction that I think is positive. So let's now define the resistor so that we can complete our analysis of this circuit. This resistor is going to have a value of 200 ohms. So this variable here, this unit here is in ohms, and it's drawn as a capital omega. Now, I've defined the voltage drop across the resistor as VR, and I like to put a plus here and a minus here to show that the voltage is higher on this side of the resistor than it is on this side. And the way in which you can compute the relationship between the current and the voltage through that resistor is using something called Ohm's law, which is one of the most basic circuit rules. And that is that the voltage drop across the resistor equals the current going through the resistor times the value of the resistance. And for this to work out, that is, this voltage is in volts, this current is in amps, and this resistor is in, this resistance is in ohms, you need to have the units that I just specified. So let's walk through how you would actually figure out what the voltage drop across the resistor would be, or actually what the current through the resistor would be. You can do both now. So let's go through those steps. So we're starting out with our Ohm's law. Voltage drop through the resistor equals current times resistance. And if we want to solve for the current, we can say, what is the voltage across the resistor divided by the resistance? Now, because there's nothing else going on in this circuit now, the voltage drop across the resistor has to equal the voltage that's generated by the battery, because one of the basic circuit laws is that the voltage along any closed path has to sum up to 0. So VR has to equal 5 volts. And so if I plug in some numbers now, I say, okay, we have a 5-volt source from the battery and a 200 ohm resistor. I can compute that the current is 0.025 amps. And since 0.025 is not a great number to deal with, we'll just convert that to milliamps and write down 25 milliamps. We'll see a lot of things are specified in milliamps in terms of current requirements in particular electronic systems. Now, we put a resistor in this previous diagram and just drew it as a sort of spring-like object, but physically, that's not what a resistor looks like. Physically, a resistor looks like one of these. And one of the great things about resistors is they're usually marked with colored bands that represent the resistance. So if you go to an electronics shop or to a store and something's not clearly labeled, you can just look at the colors of the bands on the resistor to figure out how much resistance that particular resistor has. And you can interpret these colored bands using a chart like this one. This one I just happened to download from a company called Electronics Express, but there are all sorts of these diagrams floating around the internet that you can look at. And basically, you orient the resistor so that the tolerance band, in most cases it's gold, is on the right side, and then you look from left to right at these individual bands. And you say, let's look at this first band here and look at its color. In this case, it's green, and so you would say the first number is 5. And then the next one is blue, so the next number is 6, and the last one is yellow. And so that number is 4. And so if you actually want to now compute what is the number, you say, well, I'm going to have a 5 and then a 6, and then it's, because this is 4, that represents this 10 kiloohm multiplier. It's actually 10 to the 4th ohms. Then it says it's 56 times 10 to the 4th ohms.